Hello friends, myself Rishyaj Rathod. Today we discuss about my and same paper, transforming unstructured data for ML, exploring the vital role of legal classification and feature extraction techniques in grievance redressal processes. Data transformation, transforming unstructured data for machine learning, understanding the process of and importance of data transformation in grievance redressal. Introduction to unstructured data. Unstructured data refers to information that does not have the predefined data model, making it challenging to analyze the utilize the effectively. Importance of data transformation. Transforming unstructured data into structured format is essential for the machine learning models, enabling the better data analysis and predictive modeling. The role of legal classification is crucial in grievance redressal as it ensures that the complaints are categorized correctly, allowing the appropriate responses in and actions. TF-IDF explained. TF-IDF term frequency inverse document frequency is the statistical measure used to evaluate the importance of word in document relative to the crops assets in feature extraction for complaint text. Understanding the word embedding, the word embedding are the type of the word representation that captures the semantic meaning embedding model to understand the context and the relationship in the complaint text. Significance of transformation. The transformation to understand the data into usable formats through the techniques like TF, IDF, and the word embedding enhance the performance of machine learning model in grievance redressal. Data science life cycle. Data science project life cycle. Stage, objectives and tools. Stage. Define the problem. Objective. Define the objective and scope of the project. Key details task. Understanding stakeholder requirements. Formulate question. Tools library. Project charts. Jupyter notes. Data collection. Gather relevant data for analysis, use web scraping IPs or database. Pandas, beautiful scope SQL. Data exploration and pre-processing. Cleaning and explore dataset, handle missing values, visualize data distribution, pandas and metafooling, seaborn. Feature engineering. Create features that enhance model performance. Select, modify, or combine features. Scikit-learn featured tools. Model selection and building. Choose appropriate algorithms and building model. Train multiple models. Tune hyperparameter. Scikit-learn, TensorFlow, on Keras. Text mining overview. Text mining in Grievance redressal system. Leveraging text mining for efficient grievance management. Role of text mining. Text mining automates the process of analyzing grievance, embellishing organization to quickly identify, categorize the issue based on unstructured data. Data collection. Rather unstructured data from the various sources such as emails, social media, and customer feedback forms. Data cleaning. Remove irrelevant information, correct types of standardized format to prepare the data for analysis. Tokenization. Break down the text into individual words or phrases to the facilitate easier processing and analysis. Stop word removal. Eliminate common words Example, and the is. They do not contribute meaningful information to the analysis. Streaming the lemniscation reduce the word to their root forms the ensured different variation of the word are treated as the same term. Features extraction convert text data into numerical feature that can be used in machine learning algorithm for further analysis. Segmentation analysis. Analyze the emotional tone of the text across public segment regarding grievance. Linear regression. Linear regression concept of algorithm. Understanding the fundamental and implementation of linear regression. Definition of linear regression. Linear regression is a statistical method used to model the relationship between dependent variable and one or more independent variable by fitting a linear equation is obeyed data. Fit-in line. The best fit-in line is determined use the at least the squares method which minimize the sum of the square differences between the observed values and the values predicted by the line. Least square method. These methods find the line that minimize and vertical distance between the point and the line, ensuring the best possible approximation for the data. Linear regression algorithm. The algorithm for linear regression involves steps such as initialize parameter, calculating prediction, computing the cost function, and the updating parameter relatively until converge. Input data point x and y. Linear regression input data points consist of independent variable x and dependent variable outcome y used to train the model and make prediction. Clustering algorithm for data points. Step by step overview of clustering to group. Step 1. Initializing cluster. Begin by the selecting initialize centroid for two clusters, which will guide the assignment of data point. Step 2. Assign data point. Each data point assigned to the nearest cluster based on the distance to the centroid. Step 3. Update centroid. After all the points are assigned, recalculate the centroid of the cluster by the averaging the point within each cluster. Step 4. Repeat until convergence. Continue the process of assignment and the updating until the clusters no longer change significantly. Round 1 output. Clusters A 1, 4, 2. Cluster B 10, 12, 20, 30, 11, 25. Initialize assignments based on the extent. Output 2. Clusters A 2, 4. Cluster B 10, 12, 20, 30, 11, 25. Centroid relocated point reassigned. Final clusters. After several iterations and the clusters stabilized with minimal changes is the assignment inducting convergence. Clustering methodology, K-mean. Partition data into K cluster based on distance to centroid. Hierarchical, build a tree of cluster allowing the multi-level relationship. Scalability, K-mean. Efficiency for large dataset linear in the complexity hierarchical less effective for the large dataset quadratic complexity. Shape of clusters. K-mean assume the as the specific clusters less effective with irregular shapes. Hierarchical can capture complex shapes and relationship. Number of clusters. K-mean require pre-specification of K number of clusters. Hierarchical determine cluster dynamically. No need for pre-specification. Visualization. K-mean limited visualization option clusters are not easily interpretable. Hierarchical dendrograms provide clear visual representation of cluster relationship. Sensitivity of to noise came in. Sensitive to outliers can skew cluster centroid hierarchical more robust and the noise can ignore outliers effectively. Classification of loan application. By detailed analysis of loan application risk classify the based on various aspects. Home. Why? Married? Why? Gender, employed, credit, rating and risk classes. Why? Data pre-processing. Impact of data pre-processing. Analyzing techniques and the matrices for enhancing modeling performance. Introduction to data pre-processing. Data pre-processing involves the transforming raw data into the usable formats essential for effective modeling training and performance. Key techniques. Common techniques include step word removal and elimination, non-essential word, and streaming to the reduced word there based from the enhancing meaningful analysis. Impact on the model performance, effective and pre-processing significantly influence model accuracy by improving the quality of the data input, leading the better prediction. Performance matrices. Prediction measures the accuracy of positive predictions, recall, indicate, and the ability to identify all relevant instance and F1 is score balance prediction and recall the comprehensive evolution. Conclusion. In summary, proper data pre-processing techniques are vital for the enhancing model performance and utilizing appropriate metrics using ensure robust evolution of the system effectiveness. Algorithm for grievance redressal system. Steps to determine the relevant IPC section. Input data. Input constraints of the complement takes as the term frequency matrix and IPC manual detailing section description. Reprocess complaint text. Remove the stop word and stream the liminize the word and convert all text to lowercase and uniformity. Create team frequency matrix. Count occurrence of the each unique term so in the complement for prepare for analyze. Pre-processing IPC manual. Extracting relevant terms from description of each ICP section facilitate the comparison. Calculate TF-IDF. Compute TF-IDF for each term in the complement of IPC description to assist an important. Compute cosine similarity. Measure the cosine similarity between the complaint term vector and each IPC section vector for relevance. Rank IPC section. Rank IPC section based on their cosine similarity score with the complaint for the most relevant matches. Return top ends section. Provide the user with the ranked list of the top n IPC section relevant to the complement. TFTID calculation and similarity. In-depth analysis of the occurrence terms frequency in complement document. Thank you. Yay!